Okay, we pick up on number 4, another math review. It's going to be another conversion. The Roman cubitus is an ancient unit of measure equivalent to about 0.445 meters. The problem asks us to convert the 2-meter height of a basketball forward to cubity. Okay, again, this is covered in section 1-5. So, very simple problem here where all we have to do is apply the unit conversion and come up with the answer. So the conversion in this case can be carried out in one step. In this case, we're going to let h equal the height of the basketball forward, who stands at 2 meters high. The conversion factor from cubitus to meters is 1 cubitus is equal to 0.445 meters, which ends up giving us then 4.49 cubity. Okay, so in this case, you notice how we set up the problem. We always set up the problem so that the old units cancel out. So we have meters in the numerator, meters in the denominator. The new unit we're looking for is cubitus. So we end up with a value now with cubitus as our units instead of meters. Number 5. A house is advertised as having 1,420 square feet under the roof. What is the area of this house in square meters? So we're going to try to figure out then what we need to do to convert from square feet to square meters. So in this case, the area of the house in square feet contains 3 significant figures. Our answer will therefore then contain 3 significant figures. So you need to be thinking about this with every problem that you solve. Also note that the conversion from feet to meters is squared. So this will account for the feet squared units in which the area is originally given. So in this case, 1,420 square feet times the conversion, 1 meter, is equal to 3.281 feet, in this case squared. So we keep our squared value. So when we divide 3.281 squared into 1420 squared, you'll notice here that the squared and the feet make this feet squared. The feet squared will cancel with the feet squared here, and we will be left with meters squared, and our answer then is 1.31.909 square meters. In this case, since we are looking at 3 significant figures, we can drop, or actually what we're going to do is round up. The 9 becomes 1, 1 becomes 10, and that moves us up to 132 square meters. Number 6, we're looking at a rectangular airstrip that measures 32.3 meters in length by 210 meters, actually meters in width by 210 meters in length, with the width now measured more accurately than the length. And all this is telling you is that when the person that made the measurement, the width was calculated more closely. So they ask us to find the area, length times width, taking into account the significant figures. So, using a calculator, multiply the length by the width, which gives us a raw answer of 6,783 square meters. This answer must be rounded to contain the same number of significant figures as the least accurate factor in the product. So you can't make it more accurate than the most inaccurate portion. The least accurate factor in the length then contains 2 significant figures. Since the trailing 0 is not significant, the correct answer then for the airstrip is as such. So that's what we calculated, 6,783 square meters. We look at rounding up and then changing the answer to 2 significant figures. So when we round this up, this becomes 6,800 meters squared. And then we're going to turn this into a scientific notation. So we're going to move this to 2 significant digits, and then 10 cubed meters squared. So 6.80 times 10 cubed meters squared. Okay, when we come back, we'll take a look at problem number 7, doing an addition and determining how we handle these significant figures.